Welcome to MSUA's Game Changers Live, where we speak with satellite and mobile connectivity thought leaders about industry trends, new technologies, and share what you need to know about the future of mobile satellite technologies. I'm your host, Lisa Dreer, and I'm really excited to introduce our guest today, Tom Kacpura. He is the Deputy Project Manager for NASA's CSP program, the Communication Services Project at the Glenn Research Center. Welcome to the show, Tom.
Thank you. I'm honored to be here.
Absolutely. Maybe you can start by giving us just a little bit of background on yourself and NASA's CSP.
Sure. I've worked at the NASA Glenn Research Center, which is located here in Cleveland, Ohio, for the last 32 years. And I've worked in a variety of different roles since I've been here. Back when I started with the space station power system. I did a number of microgravity flights where we actually flew payloads on the space shuttle, the International Space Station, sounding rockets, variety of different platforms. And for like the last 20 years or so, I've been primarily on focusing with the agencies, NASA's communications program, where we look at what's the communication for NASA satellites and supporting a lot of the activities that we do here. Worked as we put a payload up on the International Space Station to try out the next generation of software-defined radios in space. First software K-band radio, which we actually were, our group was honored with being honored into the Space Technology Hall of Fame for doing that work. We worked with then we worked with as a technology program manager for all our technology efforts in the space communications area. In the last few years, we've been focused in on looking at the commercial applications of satellite communications for NASA missions, and that's the start of the NASA's Communication Services Program, or CSP. We love our acronyms, and so CSP is the acronym we always have to have an acronym for it. So CSP is how we refer to it.
That's great. So maybe you can talk a little bit about CSP and what you're working on.
I'd love to do that. So CSP, we were formulated by the congressional direction to look at the feasibility and actually demonstrating commercial capabilities for providing satellite communications to our spacecraft. NASA has traditionally in the past worked on developing their own systems. In fact, we have our own systems where we currently use those to talk to our satellites and to any of the spacecraft we have in orbit. Well, recently, what we've seen is that as the commercial capabilities have advanced for satellite communications, we've seen that they're getting closer to the ability to be able to offer those communications to spacecraft. And so that's how we were formulated to do the feasibility of it through actual demonstrations of those capabilities so they could lead to operational services.
Wow, that is really exciting. And so this is intended to replace the TDRS network, is that right?
That is correct. So NASA's Tracking and Data Relay Satellite Service System, which is the TDRS. I love our acronyms, but TDRS is how we currently use that. It's a relay service. There's 3 satellites or clusters of satellites that are located in geosynchronous orbit, and we utilize those in order to communicate with our satellites. We primarily use that for command and technology to our satellites, but we also use it for getting data back from some of our bigger flagship missions. And so the decision has been made that we are not to replace our existing satellites, which is based on old technology, but to pursue the commercial technologies, which those systems have been advancing fairly quickly. And it looks like they're a good alternative now for replacing the TDRS system.
That is amazing. So, what does that look like, I guess, in the coming years as you start to actually implement and utilize those commercial services?
So we've got big news here. The big news that we recently did the award to 6 companies funded Space Act agreements where we will partner with industry in order to demonstrate capabilities that, and we use the word capabilities because it kind of, until they get to the services, but we want them to be able to demonstrate services to NASA, to representative spacecraft and a representative user on the ground, demonstrate services that are similar to how we would actually have services that we would buy. Kind of different from how NASA normally does things. NASA loves to do technology demonstrations where what we do with a technology demonstration is prove out a concept. What we're trying to do here is a couple of unique aspects. One is that we really went out for an end-to-end operational demonstration, so that when they complete all the work of doing the capability development and actually do the demonstration, the next phase for the company should be to be able to offer that as a service. We just didn't want to have contracts out where NASA specifies everything and says, oh, here's what you need to do and do it. We kind of left it to industry to be able to say, come back to us and propose, hey, here's how we would do it. And the way we did this was that we let them propose their approaches to us, and we chose a portfolio of 6 different companies, and those 6 companies now will be able to provide a range of different services that we can evaluate. So ultimately, after we complete our demonstrations with them, and we're partnered with them in order to make sure that they actually are able to complete this and they have the insight from us, but they can offer services not only to NASA, but any spacecraft user. Our goal was that we wanted to make sure that these services could go out to any user, and we recognize that NASA's probably, we would be the first spacecraft user to be able to use these systems. We thought that it was best that, hey, we have them put the services out for any user, whether it's other government agencies or commercial entities. But we thought that by partnering with them, we can provide that incentive for them to be able to start to develop these systems and get those services and be able to offer them.
Amazing. Amazing. So really a complete shift in the way that NASA has done things historically.
It is a big shift. And quite frankly, we had a lot of feedback from industry before we did this created CSP. We had a number of industry studies where we worked directly with industry to say, hey, what kind of services should NASA invest in, and what's the state of the art of those capabilities? And they came back to us and they said, hey, we're pretty close in terms of being able to offer those capabilities. There's a little bit of work needed to extend those capabilities out to the spacecraft, but by a large amount, the infrastructure was there and they could leverage that infrastructure. And rather than doing the traditional, putting a contract out that had all the specifics of how to offer the services, we said, hey, we want to be one of many. And so we came up with a mechanism to come out there and say, you know what, well, we want to demonstrate services and let them demonstrate the services, where we gave them input on NASA's needs for using the service, but we did not dictate to them at all how to develop the system or how the system would work. Rather, we said, as a potential user of your system, here's information that would help them in terms of doing the planning of future missions and capabilities we have now to get them all on the same page. But we left it up to them to be able to offer the system, because they're in the best mode of being able to decide, okay, based on what NASA needs, but also what all their other customers need in order to find, we call a reliable, robust, and cost-effective service. We wanted them at the end of this to have a service, and we wanted to allow them the flexibility to be able to develop those services that would be, something that would be a profitable one, that at the end, it really would be a service that they would have that would be self-standing.
Sure. So as you went through this process of reviewing some of the proposals that you received, what were some of the primary things that you took a look at, and what are some of the, I guess, primary trends that are driving this communications program forward?
So when we put this together, I mean, I'll take a step back. I'm not at liberty to discuss all the evaluation aspects, but in terms of we followed what we put in the AFP in terms of what was important to us. So the first thing that was really important to us was that they offered an end-to-end operational service. And so what we were looking for was a demonstration. We asked for them to propose a demonstration that had all aspects of how a potential user would use it within for a mission. So we wanted to make sure that as part of this, we said that, hey, here's the pieces. And in fact, the only requirements that we had in the announcement that we put out were those requirements that described how the demonstration should be conducted. We said that, we'll leave the choice of the service up to the providers. We did not dictate anything in terms of how they should be able to provide the service. Rather, we focused on two primary interfaces. We said that the demonstration should be able to talk to a user spacecraft, and should include a user spacecraft, because that to us is the key part of this. The fact that is now looking at that it's a service that needs to talk to a spacecraft. We wanted to make sure that they included those aspects of the spacecraft itself and how that would communicate, including the user terminal, which would be used to demonstrate it, and a suitable spacecraft. On the other side of this, what we did is that we said there should be a mission operations center in there. We wanted to make sure that, and this is how we would use the services, there needs to be a mission operations center in there, which will allow them to be able to send commands from their mission operations center, receive the telemetry to make sure that the spacecraft is working properly, the signals are being sent, and then be able to also be able to receive data. NASA generates large amounts of scientific data. That's a big part of why we exist. So having the spacecraft, having them have a data source and making sure that they were sending the data back, we broke our proposal down into two key pieces and followed those lines. One of the key uses we had was from the a service that would have assured data delivery for commands and telemetry, and the other part of it really is what I call the high data return. We create large amounts of data, be able to get that data from that's being generated in space and get it back to the user. And we were trying to make sure that those general cases that we had described really were representative not only of NASA, but any potential spacecraft out there. So they were generic, so that it wasn't just specific for NASA use, but it was general enough that any potential user could use the system.
Got it. So when you actually roll this new system out and it's being used, what are some of the use cases that this new network will be used for?
So as part of the demonstrations, we described 6 very general use cases. We took a look and we kind of broke down the missions that we currently conduct, and we gave them full access of what missions we currently have planned. We actually put that in the announcement so that they would have that at their disposal. But we looked at everything we looked at the different phases of a mission. We started looking at the launch services in terms of what do you need to launch a rocket? What do you need to be able to, during those early stages of the missions? We've got the assured data capability. We also have the high data rate capability. And one unique thing with NASA that probably extends out to most of the other users as well is that if you have an anomaly on board, how would you be able to support that? We felt that was critical because NASA does such a range of missions. We've got some very low cost missions, but we also have larger high cost missions, and we do manned missions. And so having the support during a time where things aren't maybe working as exactly as they were to script, having the ability to be able to now go and support the troubleshooting that will, figure out, okay, what do we need to do to get the spacecraft back on board, and working that through the communication link. Because to us, if that communication link goes down, now we lose command and control of our spacecraft. And so bad things happen if we do that. And so we were trying to make sure that we thought about the whole entire life cycle and provided a wide range of thoughts back to the providers all the way through the life cycle, so that they would understand, okay, here's the needs that a typical spacecraft that would go through a NASA mission, for example, but we went and made sure it was broad enough that it hit, any kind of mission type.
Great. Wow. Wow. So will these programs or services also play into supporting, Armistice and Halo and some of these other programs that NASA's working on?
Good question. So we are at the stage of where we are just looking at the demonstrations itself. We've planned out the demonstration phase, and we've just awarded out to the providers. Our thought was that by conducting these demonstrations and working with the providers, that would help us to understand the performance validation of industry's capabilities, and also understand how they work, the operational constructs. And another part of it is that, typical engineers, we're all focused in on how it should work. We also need to understand, hey, how would we acquire the service, and also the business models that go along with it, because we want to make sure that they're successful. And so once we've done that as part of conducting these, this will help inform us as to our approach for doing the acquisition of the services itself. So at a very preliminary stage here, we've had some early discussions on the applicability of that to the lunar domain, and that shows some promise. That seems to be a way that shows promise. But at this point, we've left that to, feeding that to some of the other centers, at least the lessons learned. So those that are directly engaged with that, they will have the benefit of what we've done here with these demonstrations, or be able to fuse that into their approach. Because if commercial services are available for lunar at that time, then at least they'll have the benefit of learning from what we've done, and utilize that into what their acquisition approach and their operational approaches are.
Understood. So when do you expect that some of the demonstrations will begin?
So the demonstrations, we've actually gone out and put a press release out that they have been awarded. We are finalizing the agreements as we speak, and we hope that the indication that they are all good, and we actually send out the signed agreements, should happen anytime here soon. Okay. And once we get that, then the agreements the execution stage, somewhere between 3 to 5 years probably is a reasonable life cycle for when we think these will be conducted. Somewhere fiscal year 26 is when we think roughly that most of them, between 25, 26, they should be done. And at the same time we're doing that, we will also use these results of these demonstrations to feed it back into our approaches for doing the acquisition.
Got it. So did you look at, I guess, or are you looking at new technologies that might play into the new solution?
So we, in the CSP project, made a conscious decision not to make this a technology effort. We left that back to the providers. Okay. And so we did not choose the choice of technologies that's associated with them. But as that's being said, we have, there are certain things that at the interfaces are going to directly, engage both sides. The user terminals are a good example of that. And so we've got ongoing programs here at NASA Glenn, as well within the agency, of looking at wideband terminals that have flexibility for software-defined changes. One of the challenges that you have for a spacecraft user is once you launch, you cannot change the equipment. And so if you need to make any changes, the only way to make changes is to change the software to provide additional functionality. And as we have, some of our missions are fairly short, and changing it probably doesn't matter. But some of our longer missions, some of our missions have gone 20, 30, 40 years. And so being able to do software uploads, which we do now for our missions, making that more commonplace, and being able to do that, to add new capabilities as they are developed, that go a long way to ensuring that, as the missions extend, then making sure that they have the ability to get their communications back to the ground, as well as control the spacecraft, and do that, with the commercial system. So there's, we want to be able to take advantage of their technologies, and as they're advancing them, we want to integrate that so that we can have more flexible missions, better missions using their capabilities. At the same time, we're cognizant of the fact that what's on the spacecraft once it's launched can't change except for the software. So we need to be smart to come up with a plan that balances the desire to be able to make those changes and do new things based upon new technology, but at the same time recognize our existing missions, are limited only by software changes to go into effect. And so there's a balance there. And, the old axiom that NASA always had was, and a lot of spacecraft manufacturers says, test as you fly, fly as you test. And so they don't want to make any changes because they know it works. Why change something that possibly could screw up? In fact, the comm system, why would you want to screw up the very thing that provides your commands and controls? And if you make a change and you're not able to access the spacecraft, then now you're looking at issues, because now you don't have that control of the spacecraft. And so figuring out a way to make some of those software changes, robust and reliable. There's a lot of work that's been done in the last 5 to 10 years to go down that concept. And so making sure we've got that integrated into our approaches, that would be a key thing to us to see as we go forward, to making sure that, the link is there and being able to adapt the changes and yet do it reliably and robustly. That's going to be key. That's key to us. And security is the other one, obviously, with all the stuff lately in the news with security is going to be a big aspect. And in fact, our major requirements that we had, the end-to-end demonstration, really focused on security.
Great. Wow. Well, this is really an exciting program, Tom, and I want to thank you so much for taking the time to be here today with us to share your insights and talk about what is happening with CSP.
Thanks, Lisa. I appreciate the opportunity to speak here. I mean, we appreciate the time to discuss this with you and your support.
Certainly. Well, as things progress and some of the demonstrations start to occur, we would love to have you back on, and maybe we can talk a little bit about what's happening as this all progresses forward.
We would enjoy doing that. Thank you.
Absolutely. I also want to take a moment to thank the Mobile Satellite Users Association, MSUA. You can learn more about the organization at msua.org. You can sign up for our weekly newsletter, which gives you all of the latest information that you need to know about what's happening in the satellite mobile industry. We look forward to seeing you next time on MSUA's Game Changers Live.